Hi, I'm Mike McLean. Like myself, many people have found building and flying radio control aircraft a great way to relax. It's a chance to do something that is purely fun for a few hours a week, and it helps relieve stress. Our first article is about a group of individuals that fly radio control to challenge themselves and their aircraft in a very special race. Less than half of the racers will even complete the course. It's across 20 miles of the Mojave Desert. Let's go to Taft, California, where it's 11 a.m., but it's already over 100 degrees. Taft, California, home of oil rigs and giant thermals. The land around Taft is a patchwork of dry, arid desert and irrigated fields. On hot summer days, this terrain generates powerful thermal activity. Once a year, flyers are given the opportunity to push their cross-country gliders and their flying skills to the limit in the Western Great Race. The Western Great Race is sponsored by the Thousand Oaks Soaring Society. The race took place the second weekend of July in 1988. The race is not for the timid. These competitors press their aircraft 20 miles across California desert. The route is 10 miles out and 10 miles back without touching down. The shortest flight time wins. It sounds simple enough, but the course is a real challenge. Just finishing is considered victory for many racers. Launchers are set up in a large open area. Aircraft are assembled and test flown for final trim adjustment. Before entering the course, the pilots use the staging area to gain as much altitude as possible. This is free time, and the higher the aircraft, the farther you can go before you must thermal and gain altitude once more. How high must you go before entering the course? Pilots told us between 2,000 and 4,000 feet, or until the horizontal stab starts to disappear from sight. So a good set of eyes gives the pilot an advantage of starting the race higher and working the thermals higher. A bulletproof glider is also an advantage due to speeds exceeding 100 miles per hour. Aircraft are lost in two ways in a race like this. First, an aircraft can shatter due to excessive speeds, returning to the ground in pieces. The other is when a pilot blinks or loses sight in the vast blue sky, leaving the glider to spend the rest of its life wandering over endless desert. Each team is assigned a frequency for the entire race. A pilot can launch as often and whenever he likes. This factor eliminates the luck of the launch, and each team depends entirely on judgment and flying skill. Competing as a team, anyone can take the controls of the aircraft, so each team must have at least one person that can find lift and make the right moves. Cruising at 50 miles per hour, the plane passes through lift very quickly. The driver cannot fly the plane. In fact, it is recommended that the driver never watch the plane for safety reasons. If a team is unable to complete the course, they simply pick up the plane, return to the launch site, and start over. The rules of the race are simple, such as no driving over 65 miles per hour. But the tactical possibilities are complex and sometimes devious. Consider a situation where Team A has found tremendous lift and is gaining altitude rapidly. Along comes Team B. Team A moves his plane across the street where he knows there is sink, and with this excess of altitude, circles as if sitting on a great thermal. Team B, in bad need of lift, heads right for the trap. Team A now heads on down the course without revealing the location of the good lift area, leaving Team B hopelessly low on altitude. Another important member of the team is the spotter. He helps keep an eye on the plane as well as on the other competitors. The spotter lets the pilot know when there is a turn in the road and is on constant lookout for the next usable lift area. Dust devils, dust in the air, or birds circling can indicate lift.
How are you guys doing?
Not bad. We got 6.5 miles down. We've done 6.5 miles in how many minutes, Fred? 15?
Right now we're at 15 minutes and 20 seconds on.
Okay. I'll help you guys. Isn't that nice?
Hang on.
It's already gone.
Let me make some turns on this one. This one is
going that way.
killer.
Hang on, he hit a little spot there. You sure?
Yeah, it just really kicked up.
Okay.
Well, you can see the climb and the turns.
Yeah, you're in good shape.
How much time down here, Fred?
Right there, 16 minutes. Bingo.
How much time have I been stopped?
You've been stopped for 4 minutes. Thing sure flies good. Here. Go on out front. Thank you very much. Cheers.
Thanks for the escort.
Well, we'll have one of those for flying.
Or, is that heading correct?
That
Right
is
on
a
target.
good heading.
Well, about
Excellent
five,
heading.
about five
Now
knots.
get your elevator trim adjusted.
About
'Cause you're
5
still
knots.
climbing. So if you click it down, maybe help.
Here is a team at the halfway point. The timer sights the aircraft and lets the pilot know when he has passed the turnaround point. With 10 miles to the finish line, altitude becomes very critical. This is the man that has dominated the competition by winning all of the Western Great Races held so far. Joe Wirtz and his wife Jan are both aeronautical engineers. Jan works with the cross-country team as driver.
Joe, how was that flight?
Well, that was wonderful. It was nice to hit some good thermals finally on course and do the course in a credible time.
What was your time?
37:51, if I remember correctly.
Isn't that a course record?
The course record was last year when we did it in 31:58. So this year it's a little slower, but the thermals aren't as good this year. And the course is longer, thermals aren't as good, and there's a lot more green watered crops on course. It puts a damper on things.
How's your plane flying today?
Very nice. I did build some new tips here for it, but I went back to the old speed tips, which were 8 inches shorter aside, run the wing loading up a little higher. And that's the one to really go fast. This is just better quality airplane for moderate flying. The one we were flying is only 11-foot 8-inch span and weighs about 10 pounds. And it's very much a speed airplane for strong lift conditions, which Taft excels at.
What's your technique out there?
You can put it in real simple terms. Go slow or circle and lift, and go fast or sink. Gets a lot more complex than that once you start thinking about it, but there's a couple of keynote things to remember is don't ever get low. If you're below 1,500 feet, you're too low. And you saw me do that a couple times on course, and that's, I need to slap myself and say, you can't do that. With the exception of that one time about 8 miles out, we're just about 3 miles from the turn, we're in a booming thermal, and 3 other airplanes are there. So we just raced to the turn, raced back, and nailed the thermal and climbed back up. So there are some tactical things to do also.
Sunday morning pilots ready their aircraft and discuss ways to improve their performance on the course. Even though the course opens at 10 a.m., the good thermal activity begins closer to noon. Teams constantly watch for developing thermal activity. Joe uses his fiberglass hand launch glider to pass the time and get the feel for the lift conditions.
Bad catch, Joe.
Joe has an uncanny sense of when good lift is approaching. When conditions look right, Joe's team goes into action. The truck is ready and the plane is connected to the launcher. Joe Wirtz and his friend were curious what it looks like to be riding up a launch and flying on board a cross-country glider. So they mounted an 8mm video camcorder to the fuselage looking over the tail. So if you're ready, let's take a ride aboard Joe Wirtz's cross-country glider.
Fatal left. Want me to hold the tip up on the side?
Nope.
Okay. Are you ready, Gary?
I'm ready.
Okay. Down elevator. Launch.
Because cross-country is flown at such high altitudes, it is often impossible to tell what the plane is doing. We asked Joe Wirtz to describe a device called the thermal sniffler, developed to inform pilots whether the aircraft is gaining altitude or sinking.
Okay, the thermal sniffler is a required element for cross-country. Due to the altitudes you fly at, you really can't see if it's going up or down, but this little creature will tell you that. Its mode of operation is simply when you're climbing, the better you're climbing, the higher the tone is that it transmits down to the receiver that the pilot is listening to. And if you're in sync, the tone goes lower. It works basically by it being in an enclosed box, and when the airplane goes higher, it's going to a place with less pressure, so air goes out of the box slowly. And it has a very sensitive metering device that picks up the flow in or out of the box and how fast it's going. And because of that, it translates that to a tone that transmits down to the pilot, and therefore he knows what the airplane's doing. Anyhow, there are some things you can do to it to optimize the performance for sailplane flying, rather than just putting it in your aircraft. You just put it in your aircraft and fly around. When you pull up or dive down, you hear stick lift and stick sink. And that's not very optimal solution because you're hearing what's the airplane doing rather than what the air around the airplane is doing. You want to know that you hit a thermal, not that you accidentally gave it up elevator. So taking a lesson from the full-scale sailplane pilots, they created something many years ago that they call total energy system. And it's very simple. You hook up to the intake to the box, basically through a little tube, and put out a little sensor, hook up to the tube a little sensor outside of the aircraft that has, it's basically just a cylinder with some holes on the back side, on the back edge of the cylinder, and the top of it being capped off. And what that does is it technically gets a coefficient of pressure of -1 into the sniffler box, or it will subtract the dynamic pressure from the static pressure. And the net effect is you don't hear stick thermals anymore. You can be flying along straight and level and push the airplane down elevator and it'll dive. And because the airplane's picking up speed and still really hasn't lost much energy, you don't hear any change in tone. Or alternatively, you pull up and you don't hear a change in tone. You just hear the amount of energy in the air around you. So it's really nice if you're going very fast, you hit a thermal and you zoom into it and do a nice climbing circle into your thermal, get an optimal thermal start, and you just hear the air around the aircraft, and it really helps out a lot.
One to keep the camera off the ground. Real nice.
Of the 12 teams that started the race, only 5 were able to complete the course. Out of the 5 teams finishing the course, only 2 teams completed the course on both days. The shortest time and first place went to Joe Wirtz. Second place was captured by Larry Jolly's team, the only other team to complete the course both days. Larry's team also turned in the longest time on the course of 63 minutes 59 seconds. Third place went to the Faux Pas team with a time of 42 minutes. Well, it's off to the hobby store. Let's go to Terry's. When you need a tool or an accessory, a good hobby store can be a great asset. After Terry shows us what he likes in accessories, we'll be going to Fort Huachuca, Arizona, the headquarters of Army Intelligence and the home of the UAV platoon, the Army's remote piloted vehicle training program.
Hi, welcome to our shop. My name's Terry Edwards. I have a few items I'd like to show you this afternoon. We have some products that just came in from Ernst Manufacturing Company. These two are push rod exits. One's for the large one, the blue push rods. The other one's for the small red one. They're good looking exits. I think that's a real nice product. They also have 4 different sizes of tail wheel brackets. They have a little bitty one here for half A. Goes all the way up to quarter scale stuff that would handle an 1/8 inch wire. Those look like a pretty good item. Here's one that I like. It's a prop balancer that's small enough to carry in your pocket. It has bushings that you can use any different size prop you have, and you can take this right along the field with you. I know you people never break any props or anything, but if it should happen, if somebody stepped on your airplane and you ended up needing to put on a new prop, you have this in your field kit. You can balance the prop right on the job. Very simple, economical little product. This one is a security clip for servo extensions. You plug those extensions into your servos for big airplanes. This is a clip that holds them together to make sure they don't disconnect and give you a problem in flight by losing your ailerons or something. That will maybe save you an airplane sometime. They make a super stopper for Sullivan tanks so that it won't dribble down into your fuselage and make a mess. This is one I really like. They make a charge receptacle for Futaba, and this little giddy is a plug cover. Now, I know that nobody out there ever wrecks their airplanes, and they never have any problem with getting dirt on their equipment or anything. But if you should get a little dirt in your charge receptacle on landing, you may not see it and give you a problem. This is just a little plastic cover that folds up and covers that hole up so that you don't get dirt in there. I like that. These are some new engine mounts they sent. I think that you'll find these are pretty good product. They make them several different sizes. There's a 10, a 20. This one is a 24 stroke with the longer legs on it. Here's a 40. They have a 60 size. Looks like it's probably not big enough for anything bigger than a 60. You may not put a 90 in it, but it will handle a 60. And then this is for a 64 stroke. Long mount, so you got plenty of room to work with your 4-stroke engines. These are lightweight. They look like they're a good solid material, and one feature I like about them, there's a bolt here, an Allen screw and a nut. You can loosen that and make them wider to fit the engine you're using, so you don't have a lot of slop in your engine mounts. That looks like a real good idea to me. Okay, I have one more item from Ernst that looks like a good product. I'm kind of enthusiastic about this. I've never used these. They're thrust plates. There's a 20, a 10, or sorry, a 20 and a 40. They don't make a 10, and a 60 size. These things will let you set the thrust angle on your engine by merely moving these plates around. Each one is cut as an angle, so you adjust these shims to get left thrust, right, up. I don't think you need any up, down. You can put them all together, and it gives you the amount of degrees of thrust that you want. This is a pretty good one here. It's all up and left. That'd be a good combination. Now, one thing about these thrust plates, you see that they're square. They have a scored line around them so that you can trim them to use them on a round fuselage, under round engine mounts. So you don't have to make your round airplane square just to use these thrust plates. That looks to me like a real good idea. I'm going to use a set of these on my next airplane. While we're talking about engine mounts, I have another product here I'd like to show you. This is made by Performance Products Unlimited. It's called the Vibra Mount. This is for taking the vibrations from your engine and leaving them at the engine and not transmitting them on into the airplane. One of the other features of eliminating vibration is that you also cut down on the noise, the overall noise of your airplane. This engine vibration is transmitted through the whole airplane, which acts kind of as a drum and makes the airplane louder. The heart of this are some brackets that attach to the back plate of your engine. Then these little shock mounts, those look to me like old Cessna 170 instrument panel mounts. Sure enough. Well, you screw these into a nut plate on your firewall and then attach the engine to it with these little tabs that you've already hooked to the back plate of your engine. So when you've got it bolted on the firewall, the engine can move around and it absorbs the shock so it's not transmitted back to your airplane and into your radio and foul up your radio system. They say to use this ring on the nose for low speed if your engine is shaking quite a bit. I can see where perhaps with these shock mounts you might get a lot of movement out of this engine at idle speeds. So they put a damper ring around the front so that the nose of the engine, the crankshaft, is restricted for how far it can move. It looks like a good idea. This looks like an interesting product. Some of these engines we use vibrate quite a bit, especially if you're not using your prop balancer like you should. Another product I have down here that I want to show you is from Ace. As long as we're running that engine, this is the TACmaster. Not Taskmaster, TACmaster. This looks like a real quality unit. It's set up for a 5,000, a 0 to 5,000 RPM range, a 0 to 10,000 RPM range, and a 0 to 25,000 RPM range. Now, for you hot shots that run your engines over 25,000 RPM, I can't help you on that. You could use the 0 to 5 for setting your idle speeds. and getting a real good, accurate readout of what your idle speed is. I like this analog readout. It makes more sense to me than a digital. You can really see what your engine's doing, and I like it better than using digital on a tack. So then, when you're ready to go, this has the little sensor right here. You point it at your propeller. They recommend about 6-8 inches away from the engine and about 2/3 of the way out on the propeller. You push this button, it comes around and reads your RPM. That's simple enough that even I can handle that. I think I'm going to be able to use this. While we're talking about ACE, I'm a sucker for tools. Anybody comes out with a new tool, I have it. I have all kinds of pin vices in my shop, and they never have the right size bit in them, and I'm always losing pieces. Real pain in the neck. ACE has come out with the world's most efficient, simple pin vise I ever saw in my life. This is 1/4 inch. They have sizes 3/16, 8, clear down to 16th. And according to the instructions, this little rascal is for printed circuit boards. I know nothing about printed circuit boards, and I'll probably use that one for something else. But this is so handy for drilling a small hole. I could go through this piece of 1-inch pine in real short order. Those are nice. You don't have to get your drill out and chuck up the drill just to go through a piece of balsa wood where you need a hole. I like this product. ACE has given that some thought. Sometimes the simplest things are the hardest to come up with, but that's simple and it works well. Okay, I have another tool to show you. I've heard of incidence meters for a long time, but I've never used one, so it's time for me to get caught up to date and get my airplanes rigged up so they're straight and fly straight. This is a Robart incidence meter that is really an easy thing to use. It looks good to me. If you like, we can open this up, take a look at it here. I think that we can check and see how well, maybe we'll check and see whether the counter is level or something. It isn't the easiest thing to unwrap. I love this plastic wrap. But sometimes you have to get a little ornery with these things to get them apart. I don't want to break anything. Getting a little too mean with that one. It doesn't want to come out of there at all. Thanks, Robart. You really did a good job of wrapping that. I'll probably destroy the product before we get it opened up. This is the part you need to be kind of careful with. That has the level and the meter in it. There's a book. You know, when all else fails, read the book. Model Incidence Meter Instruction Manual. Well, we'll see how it works first, and then if it doesn't work, we'll go back and read the book and see what they say. This bar is an aluminum bar, slides through the back of the meter itself. With any luck at all, I'm going to try the other end. That one has a little bit of a burr on it. It needs to be cleaned up. There we go. I'll probably run it through my hand and end up in the hospital before I'm through with this. But remember how I said you have to be careful with this, not banging around, take it easy? That's not a good example of what I just did there. These pieces have little clamps on them that let you line it up and let you make the width right for the size of your wing. There we go. That puts it together. These are on a swivel, so you can go to the leading edge and the trailing edge of the wing in there. Oh, won't work. My counter is too wide a cord, I guess. Let's see if it's level. No, don't set your coffee on there. It'll probably spill. There's a level, so you can level the airplane. And then you can read what the incidence is on a plus or minus scale. Looks like up to 10 degrees. That ought to be enough incidence for anybody. Now let's clear a little space here. I have another item I want to show you. Like I said, I'm really a tool nut. So anything that comes in the category of tools, I really like to look at. I have Byron's new tote box here, their field kit. This is really dandy. Even I can put this together. Everything pops in place. I didn't have any problem with this at all. I wired my meter in, or my power panel. Just took a few minutes. The plastic cut through there, drilled 4 holes for the corners and cut through with a saber saw. And I have my power panel in. My gel cell battery is down here in this compartment, all hooked up. Here's my pump all ready to go, and the bottle of fuel sits right in behind this. This will also hold a square can of fuel. You don't have to use a round plastic bottle. And then there's plenty of room for all your other goodies in here, some props and a starter or two and anything you need, of course, something to clean your airplanes with. This is a nice kit. I really like this. I saw it in a lot of the ads, but until you get it in your hand and feel it and see what it looks like, it really turned out to be a good item. Okay, we'll put this away and go on to something else here. Oh, thank you for the mail. Here, want some nuts? Have some nuts. I love to do that. That's what makes this business fun. This is an ACE, another ACE meter, an ACE Voltmaster. I wanted to show you this. I have several expanded scale voltmeters in my shop, but this one is a little different than I've used before. It is set up for either 200 milliamp or 500 milliamp batteries. It has a switch for 4, 6, 8, or 10 cells. I've made up a little patch cable here. Speaking of patch cables, there's one thing that kind of bothers me. Maybe if there's anybody out there from the manufacturers or the AMA listening, why do we have to have so many different kinds of connectors? I think it's about time to standardize things. Why don't we all use the same connectors so I don't have to build 387 different patch cables just to check a few battery packs? Well, I don't know if anything can be done about that or not, but that's one of my pet peeves, and I think that we could standardize that system and have a lot less grief for everybody. Well, let's go ahead and check a battery here. This plug is all set up to hook into the charge receptacle on my ship's battery, and it's a 4-cell battery, so we have it set it on 4, and it's about a 100 milliamp battery. Set it down here to 200. Now when I plug it in, it shows we have voltage. It's in the middle of the green arc. Well, it may be that we have voltage, but if that battery isn't really up to snuff and we turn on the transmitter and go fly it, that may be all the voltage it had, and we're dead. So with this load on the voltmeter, we can check the battery, leave it on about 15 seconds or so, and you can see the needle comes down initially when you put the load on, but then it holds like it's supposed to. So that means that this battery has enough charge. We can get another flight out of that without any problem. That's holding real well. This battery's in good shape. So the battery's in good shape. Let's go fly it. I've been here in the shop long enough. That's what this whole business is about, is flying airplanes. Well, let's head for the slope and see how this thing flies.
One thing the platoon has worked very hard at is trying to break the image of being a group of RC model enthusiasts who just get together and go out and fly some airplanes. This is part of a serious training program that will support a very serious tool that the Army has placed great importance and priority on, and this is the UAV system for intelligence gathering.
RC Video Magazine traveled to Fort Huachuca, Arizona to see the military application of RC aircraft. Fort Huachuca is the home of the UAV platoon, which administers the Unmanned Aerial Vehicle External Pilot Training Program through the U.S. Army Intelligence Center and School. External pilot refers to the structure of a typical UAV mission. The external pilot preps and launches the aircraft and achieves a standard flight pattern. Control is then relinquished to an internal pilot. The internal pilot or pilots may be some distance from the launch site in a mobile vehicle housing the flight and mission electronics. From here they fly the aircraft and operate the payload systems over hostile territory. When the mission is completed, the internal pilots fly the aircraft back to the launch site where the external pilot lands it. The Provisional UAV Platoon was formed in March of 1986. It consisted of 1 officer and 5 non-commissioned officers. In November of 1986, and again in July of 1987, Army UAV Platoon pilots trained Marine Corps pilots to fly UAVs. The platoon was officially established in October of 1987 and has expanded to 19 members. Many of the soldiers in the program at Fort Huachuca were RC flyers as civilians. They bring their experience, skills, and enthusiasm to the program. Carefully planned and rigorous training is required for all platoon members, starting with ground school. Trainees begin with the basics of aerodynamics.
Look at it in molecules of air, the distance from the leading edge to the trailing edge is basically the same with this symmetrical airfoil, all right? So for a neutral lift, the air is passing at the same speed under as it is over. So basically it is neutral. Now for me to effect a change on that so I can use it, I will increase and decrease one side of this airfoil, all right? So by moving this control surface downward, the air now, the same amount of molecules of air are passing across the top and across the bottom. However, now the distance from this point to this point is longer. Those molecules of air are spread out.
Shop rules and safety are discussed, along with instruction in the use of hand and power tools needed to build an RC aircraft. Aircraft construction is covered next, followed by flight preparation and safety. After ground school, UAV trainees take to the flight line for Phase 1 of flight training, where they are familiarized with the basic trainer aircraft. The airplane is an ARF kit, the Das Ugly Stick, distributed by Circus Hobbies. After flight preparation, they are ready for their first hands-on flying experience. For some, it's their first RC flight. Students complete 60 hours of training at this level. The UAV platoon has been using 3 different aircraft to fulfill its training needs: the Das Ugly Stick, the Half-Scale Pioneer, and the X-Drone. Phase 2 of flight training requires the trainee to display full control of the aircraft during high and low speed taxis and 4 out of 5 attempts at takeoff without rotation. The student must also successfully complete 19 out of 20 instructor-assisted takeoffs before attempting unassisted takeoffs. At this point, 8 consecutive takeoffs are required. Pattern flight standards must now be met. These include flying square figure eights, fast and slow, P-turns, and landing patterns with throttle control. 30 hours of instruction are required before moving on. 20 hours of Phase 3 flight training follows. Students must successfully complete 19 out of 20 instructor-assisted landings, then 8 consecutive landings on their own. Learning to deal with various types of stalls is covered. The students must cause and recover from power on, power off, and turn stalls. Advanced pattern flight requires 5 successful attempts each at flying inside loops, inside Cuban eights, stall turns, split figure eights, and aileron rolls. And there's more. Rudder control of the aircraft must be demonstrated during crosswind taxis, takeoffs, and landings.
Later in the show, we will allow members of the audience.
Rudder control during flight is demonstrated by a series of ascending and descending turns, flat turns, slips, and crabs. Finally, the student must land inside a 10-foot circle on 8 out of 10 attempts. At this point, the student pilot may find RC aircraft fun, but becoming proficient is real work.
Go for Cuban 8. Right now we're having an unplanned landing. No, actually it was planned, we're just kidding. The instructor pilot was very comfortable in the aircraft. The pilot jumping out of the aircraft right now. The pilot Max Engel.
Now, after a minimum of 110 hours of training, the student is prepared for advanced or system training. The aircraft used for this training stage is a half-scale Pioneer, which is the export version of the Israeli Mastiff. The cost of the half-scale Pioneer trainer is about $5,000. The full-scale system is a bit more expensive at almost $500,000. Add a forward-looking infrared imaging system at $1.5 million and ground support equipment for $500,000. However, the aircraft will remove soldiers from high-risk situations and fly many missions providing valuable information which would otherwise be unavailable. In a battlefield situation, the Pioneer would fly a variety of missions, including target acquisition, jamming, or just providing an eye-in-the-sky capability for the ground commander.
There we go. Outstanding, Sir Cruz, outstanding. Has a steerable nose gear, so he can steer it back to our ready line here. My name is Lieutenant John Mills. I'm the operations officer for the UAV platoon of the United States Army Intelligence Center and School. I'd like to welcome everybody this morning to our flight demonstration. This is our first flight demonstration for the platoon. The platoon's mission is to provide personnel and support to the United States Army Intelligence Center and School in the development of unmanned aerial vehicles and the various subsystems that go with them. Subsystems such as payloads, communication relay devices, and other sensors. This will assist the United States Army Intelligence Center and School and the Military Intelligence Corps in developing a deployable and operational UAV platform. One of the most sophisticated and advanced systems we fly is called the X-Drone. The X-Drone name comes from the term expendable drone. This was originally developed beginning in 1972 as part of a joint United States Army, United States Marine Corps project to develop an expendable drone for use in electronic warfare jamming missions. the airframe would be launched, it would perform a jamming mission, and then it would expend itself when it ran out of fuel and drop to the Earth. We use the X-drone now for several different missions, and it is our most advanced bird, and it takes the most skill to fly that bird.
Maintaining a large fleet of trainer aircraft means lots of parts and materials. The platoon buys servos by the dozen, props by the hundred, batteries and epoxy by the case, and fuel by the 55-gallon drum. When a plane crashes or is pooched, as it is referred to, any usable parts are recycled. Getting new parts takes some work because RC equipment is not Army standard and can't be ordered by a military part number. Platoon members research parts through RC catalogs and submit a request. The Army Procurement Agency then collects bids from suppliers. The suppliers are the same as those a civilian hobbyist might use. The time from request to receiving the part ranges from 6 months to 45 days, lightning fast by Army standard. The UAV platoon has exceeded world records for radio-controlled aircraft time aloft and distance. Using an X-drone stripped practically to a gas tank and wings, 2 UAV pilots in helicopters leapfrogged from Fort Huachuca to New Mexico and back, covering 565 miles in 7 hours, 38 minutes. Fort Huachuca has been identified as the Department of Defense training site for all unmanned aerial vehicle programs. The basic purpose of UAV systems is to provide unique capabilities to the battlefield commander while saving U.S. soldiers' lives by removing them from high-risk situations normally required to provide those capabilities. Next, Ed will review the new Concept 30 helicopter. Take it away, Ed.
Hi, Ed Nakasone for RC Video Magazine. In this Breaker Blade article, we'll be reviewing the Kyosho Concept 30 helicopter. This model is imported and distributed in the U.S. by Great Plains Model Distributors of Champaign, Illinois. The Concept 30 is a 28 or 32 engine size helicopter. It was designed by the 1986 World Helicopter Champion, Mr. Shigetaka Taya of Japan. It comes with auto rotation as standard and can be operated with either a 4 or 5-channel helicopter radio. However, a 5-channel helicopter radio is highly recommended. The Concept 30 has 2 designations, the DX and the SE. The DX is simply a trademark designation associated with the model, whereas the SE stands for Special Edition of the Concept 30 helicopter. Now, Great Plains have made available 4 different packages of this helicopter, all requiring some degree of assembly. First being the sub-assembled DX helicopter without engine, the sub-assembled DX helicopter with engine, and the DX in kit form without engine, and for the experienced flyer, the SE helicopter without engine. Now, both DX and SE models are identical in design. The difference being the DX is a basic helicopter which is aimed towards the new flyer. It has aluminum flybar pedals for smoother handling and 8 ball bearings at major rotating points, whereas the SE is aimed towards the experienced flyer. It has plastic flybar pedals for quicker control response, and it incorporates 28 ball bearings throughout the major rotating points. In this review, I will be assembling the SE kit. Later in the program, we will view the almost ready to fly DX helicopter prior to its final assembly. Let me place this helicopter on the side for now. Now, let's look at the contents of the SE kit. The entire helicopter is neatly fitted in this box. First item we see is the decal sheet. This is great for finishing. There's no painting required. Next is the instruction booklet. I received both the Japanese and English version. I will elaborate on this booklet later. Under the booklet is the plastic canopy with smoke windscreen. Here's the parts box. I'll set this aside for now. Under the protective cardboard is the main rotor blade. And with that is the tail shaft unit, along with the tail rotor drive wire and the pitch control wire. Let's look into the parts box and see how they package these items. Here's the main frame assembly along with the main rotor shaft and gear. Next is the tail assembly with landing gear, the servo tray assembly, the fuel tank with associated fittings and fuel line. Let's open the bag containing the main rotor head assembly. Note how each part is individually packaged and each package identifying its content. For this kit, I selected the OS-32FH engine. The instruction booklet. This is a comprehensive instruction booklet for the DX assemble model. It was written and organized for the new flyer. I highly recommend reading the entire booklet before construction of the helicopter. Do read the warning and important notes before proceeding, however. The first section provides information on the required equipment such as batteries, fuel, etc. Next, you'll find detailed instruction on the construction, layout, and adjustment of the Concept 30. Be familiar with this section. It works well. This is followed by a section on control checks, followed by engine starting and troubleshooting, followed by an explanation on how to check, adjust the main tracking of the rotor blades here. It also provides basic flight instructions to include auto rotation. This is followed by a parts list, and it also provides diagram of the exploded view of the entire helicopter. With the absence of an instruction booklet for the kit, I used the exploded diagram to assemble my SE kit with minor difficulties, which I'll elaborate later. Also included is a supplemental instruction for more detailed and comprehensive instruction on how to get your helicopter airborne. All in all, I find this to be an excellent document. Before you begin the assembly of the subunits, I highly recommend laying out the screws, nuts, and washers by type and size in this manner. Construction of the subassembly. Assembly, construction, and adjustment of the SE kit took me approximately 8 hours. As stated earlier, I used the exploded view to assemble this kit. Therefore, no step-by-step assembly procedures was available. However, if you study the diagram and lay the parts out, assembly is straightforward, but a few suggestions would be helpful here. As an example, this tail rotor assembly. When you assemble the center hub, ensure that the threaded stock, which is numbered 141, locks onto the output shaft outer hole. This will prevent the hub from spinning or flying off during the flight. Before you tighten it, however, ensure that you install this set screw, which is numbered M3x4. Go ahead and install the set screw, then lock the threaded stock onto the shaft assembly itself, and above all, use a lot of Loctite. Now, before you assemble this tail rotor case assembly, ensure that the tail boom itself is installed simultaneously. This case assembly has a little lip here which locks the tail boom together onto the tail rotor case assembly. As in this manner here. Okay, let me lay this on the side for now. Now the main frames. This is really a sturdy, heavy-duty plastic. When you take this out of the kit, you'll find that when you place the side frames together, that they don't match perfectly. As a matter of fact, it's warped. Don't worry about that. That's part of the manufacturing process, so I was told. Because as you assemble the side frames together by installing the gears and the alignment devices, as you pull it together, you'll find that everything will fit perfectly. Even the gear mash will be running real smooth. As a matter of fact, there's no adjustment to the gear here. But before you tighten up the main frame assembly, ensure that the lever set, especially the 4.5 lever set here, are installed on the side frame prior to tightening it up, because it's almost impossible to get the lever set installed once the side frame is assembled together, as well as the left and right and the pitch lever set here. As for the servo tray assembly, there's really no problem. It's pretty straightforward. However, when you attach it to the main frame, ensure that the fuel tank is assembled simultaneously. If not, you'll never get it in there. As for the cooling shroud, this is really a high-grade plastic here. It was really designed around the OS 28 size engine, and it fits perfectly. However, in utilizing the OS 32 engine, I found that I had to do some little trimming of the plastic here to ensure that this thing fit and ran free with the fan assembly hitting the shroud, without the fan assembly hitting the shroud.
After having said all that about the subassembly, if you bought this DX assembled helicopter with engine, everything is put together for you. Therefore, I highly recommend this format for the newcomer.
In the DX assembled kit with engine, what you have is your parts bag, your landing gear assembly, your totally assembled mainframe, servo tray, and engine assembly here, a totally assembled tail boom and tail rotor assembly, the main rotor head assembly, rotor blades, and your canopy. Great for the newcomer. Final construction of all sub-assemblies is straightforward. Just follow the step-by-step assembly and adjustment procedures as outlined in the instruction booklet. As far as the ball links are concerned, ensure that the word Kyosho faces outwards when assembled to the ball itself. For the initial kit, I utilized on the servo wheels the standard 10 millimeter wheels here. However, I found that for my throttle assembly, I had to utilize the larger wheel to ensure that I could have the required throw, as well as to have the linkage clear the frame assembly itself here. For the initial flight tests, I did utilize the 10 millimeter wheels and found it to be adequate, and it's perfect for the beginner. However, for the more experienced flyer, he may want to utilize the 15 millimeter wheel, the larger wheels, to achieve the desired results.
Use the pitch gauge which is supplied in the kit. Use the recommended pitch setting. For the newcomer, refer to page 10 on blade pitch adjustment. As for the tail rotor blade, ensure that it is set at 0 with the transmitter throttle lever set in a down position.
As for the gyro check, Ensure that the blade is corrected in the proper direction as shown here. The head and blade assembly should be balanced on the high point, but the procedures as outlined on page 4 is adequate. Attach colored tape for ease of blade tracking. Check control movements as outlined in page 12. In conclusion, this was a fun kit to put together and to fly. There are more likes than dislikes. First off, I like the quick, easy construction. It's almost a snap-together kit. I like the detailed instruction booklet with supplement. The quality of engineered parts, just a perfect fit. The high quality of plastic material, superb. The stable flying machine is great, snappy tail response. I like the upgrade of the DX to the SE model. And lastly, I really enjoy the quick disassembly for portability of this kit here. As for the dislikes, I really did not like the single tail shaft drive bearing, but I understand they're going to be coming out with 2 of these bearings to prevent tail whipping. I uncovered small cracks on the leading edge of my blades. Sent that back to the factory, but I was told that it was probably fluid in such too cold of a weather. However, Great Plains is coming out with a wooden blade for this particular model. I really dislike the SE kit without instructions, but as I indicated, I followed the exploded view and that worked out great. The Concept 30, I feel, is a real winner. The newcomer will like the DX almost ready to fly kit with engine. For the experienced flyer, he will want to put the SE kit through its paces. Let's run her up. Seems like it is somewhat on the rich side. Need to lean her out a bit. Because the engine is new, I'll keep it slightly on the rich side. Let's run her around a bit. Very smooth. Let's see how it performs in the air. Loops easily. How about a roll? No problem. Auto rotation? Not bad. The Concept 30 has barely been on the market, and there's already several upgrades for it. As I indicated earlier, there'll be 2 tail drive shaft bearings in the tail boom. There's also going to be a black anodized tail boom from Great Plains. Also is a aluminum cone starter here to include a wooden blade for this kit. As far as aftermarket products, Rototech Engineering also has developed a tail drive shaft system for this helicopter. And as you can see, Mack Muffler has designed a neat header system with the Wizard muffler for this helicopter. For this review, I'd like to give special thanks to
Lots of new scale airplanes showed up for the 88 Nationals in Norfolk, Virginia. We arrived in time for the static judging, which began early Friday morning.
This is Fennis Field Naval Air Station and the site of the 88 Nationals. The staff at AMA acquired a beautiful site for the competition. If F-14 Tomcats use the field, it should be ideal for the 72 scale planes and their pilots participating this year in the RC scale category. Before the flying portion of the competition begins, each plane must go through static judging. This was conducted at a nearby public school gymnasium. Contestants lined up at the door waiting for room to squeeze into the judging area. We took advantage of this situation to get up close to a few of the aircraft. This 1/5 scale SPAD 13 was built by George Rose and is entered in the FAI scale. Wayne Knight designed and built this Hawker Typhoon. It's entered in the giant scale category. There are 6 different categories of RC scale this year. Giant scale is the largest with 29 entries. A new event this year is the FAI Giant Scale with only 2 entries. This category will probably grow at future nationals. Here comes Colonel Art Johnson with his new B-26 Marauder. This 30-pound bomber is controlled with 13 servos, a very impressive model. Aircraft are weighed and set before the judges. Using the documentation supplied by the contestants, judges score the aircraft for outline, color, markings, and craftsmanship. Judging model aircraft, either static or flying, is not an easy task and takes uncommon dedication to the sport. Scale is very popular at the Nationals, and any floor space not filled with aircraft was taken up by enthusiastic spectators. Saturday morning round 1 started early. Because of a tight schedule, it was necessary to fly 3 rounds the first day. We always admire pilots that can stand in front of judges and spectators with their aircraft, which may have taken years to build, then take off and fly the required maneuvers in a fashion similar to the full size, land and taxi back as if at their local field. Of course, the pilot may be feeling closer to panic and greatly relieved when their plane is back on the ground. When standing at the flight line watching the competition, it's easy to forget what it takes to compete in scale. A pilot must be a craftsman, an engineer, a historian, and an artist. For the 12 minutes he is given to fly, the pilot has an opportunity to convince the judges he or she knows more about the aircraft than the intimate structure, color, and markings by showing that they know exactly how the craft flies, what the full-size aircraft could do and could not do. It's a combination of skills hard to compare with any other activity. No matter how perfect a flight may seem, sometimes the most critical moment is when the wheels touch down. Most pilots would agree the landing is the most difficult maneuver. Maybe that's why when a pilot sets his ship down in a perfectly executed landing, you can hear a sigh run through the crowd, and often applause. This may be the moment it is easiest to forget you're not watching a full-size aircraft. Let's watch some of the contestants perform scale landings. Here's Wayne Knight's 24-pound Hawker Typhoon. Wayne won the NASA Flight Achievement Award with this plane, as well as taking 6th in giant scale. Coming in on the final is Irv Searles' Bucker Youngmeister. Landings were never considered a piece of cake on the full size, and this seems to be true on the model as well. Realism is difficult to achieve at the Warbird landing. This is William Carper's P-47G on final. This is George Rose's Spad, setting down in a light breeze. Here, it appears the pilot let the plane slow down too much. However, it landed on its wheels unscratched. This large P-39 was built by Joe Slock. Let's watch both the takeoff and landing of this aircraft. Here comes Charles Duval's PT-19. A rough landing, but there are far greater degrees of rough landing. This is Bobby Russell's clip wing Cub. The Cub always seems to be well behaved when it comes time to get back on the ground. Here we see Dale Cordez's PT-20. Settled into final is Mike Winter's Tiger Moth. That looked nice. Let's see if he can do it again. Here comes Lindsey Smith's A6M50. This World War II Hellcat was built by Tom Dill. Here is a very unusual subject. This XP-54 was entered by Joe Salco. Joe says it flies fast and is a handful to get back on the ground. The Beechcraft Stagger Wing is notorious for the tail losing control at low speeds. Something like that. We asked Cliff Tacey, contest director, to give us an overview of this year's competition.
Yes, this was a traditional East Coast match from the standpoint of scale. We had a total